CAIE June 2006, CAIE June 2006 P3 paper. So we shall solve all the questions. So let us start without wasting further time. The first question, x is equal to 4 times e to the 3 to the power of minus y. Express y in terms of x. So I write that one. X equals to 4 times 3 power minus y. So what am I going to do? I'm going to apply ln on both sides, ln. So ln x equals to ln 4 plus ln 3 power minus y. The formula that has been used over here is ln ab equals ln a plus ln b. Now from there, what do I get is ln x is equals ln 4 minus y ln 3. That y comes front, so I need to make y as a subject. So y ln 3 is equal to ln 4 minus ln x. So y equals ln 4 minus ln x, or ln x ln 3. Some people say as ln 4, some people say as ln 4. So ln 4 minus ln x upon ln 3, or ln 4 minus ln x upon ln 3. That's the answer for y. Question number 2. There are multiple methods of solving this inequality. The first method is 2x is greater than modulus of x minus 1. So what am I going to do? I'm going to do squaring on both sides. So it becomes 4x square is greater than x minus 1 whole square. 4x square is greater than x square minus 2x plus 1. Then bring the other term, so 0 is less than, or what can I do is 4x square minus x square is 3x square plus 2x minus 1 is greater than 0. Now I factorize this one, 3x square, so it becomes 3x plus 1, 3x minus 1 times x plus 1. Is that correct? Minus x plus 3x, okay, is greater than 0. So I have the roots as 1 upon 3 and negative 1. So I get x is greater than 1 upon 3, x is less than minus 1. So always there will be two answers whenever I have greater than, So what you have to do, it is simple thing to remember, x is greater than the greater root and x is lesser than the smaller root. So over here, x is greater than 1 upon 3 and x is less than minus 1. Now we have to be very much careful what are the values, which are these two applicable, or any one we have to reject. For example, I take x is less than minus 1. I consider any number x is less than minus 1, negative 2. Then I try to plug in negative 2 over here. So negative 4 is greater than modulus of negative 2, negative 1. Negative 4 is greater than 3, which is wrong. So it's not possible. So therefore I reject this. So my only answer is x is greater than 1 and 1 is the only answer. X is greater than 1 upon 3 is the only answer. So reject x is less than minus 1. Now the parametric equations of the curve are this much. Show that dy by dx is equal to tan theta. So first, x has been given. X is 2 theta plus sine 2 theta. So what am I going to do? I'm going to find dx upon d theta. 2 theta derivative is 2. Sine 2 theta derivative is cos 2 theta. 2 theta derivative is 2. Similarly, what am I going to do? Y is equal to 1 minus cos 2 theta. So I'm going to find dy by d theta. 1 derivative 0. Cos 2 theta derivative is minus sine 2 theta. Minus of minus becomes plus. And sine 2 theta derivative is 2. Now I need to find dy by dx. Dy by dx is nothing but what? Dy by d theta upon dx upon d theta. So dy by d theta is 2 sine 2 theta divided by 2 plus 2 cos 2 theta. Then I try to simplify that. What is he asking is one to form in the form of tan theta. So what can I do is I can take 2 cancels. I'm left off with sine 2 theta upon 1 plus cos 2 theta. So sine 2 theta formula is 2 sine theta cos theta, and 1 plus cos 2 theta is 2 cos square theta minus 1. Those are the formulas. So from there what I can do is 1 cancels. Then you can still see that 2 and 2 gets cancels, and still you can see that 1 cos theta cancels, and I'm left off with 1 more sine theta and cos theta. So that becomes tan theta. So very simple. I've used the color coding. You can see that which terms are cancelled with the similar colors. Question number 4. 7 cos theta plus 24 sin theta can be written in this form. R is greater than 0. Alpha lies between 0 to 90 degrees. Alpha in 2 decimal places. 7 cos theta plus 24 sin theta. So what you have to do it is you have to identify A and B. So A is 7, B is 24. So first find capital R, which is square root of A square plus B square, which is square root of 7 square plus 24 square, which is 25. So what am I going to do? Multiply and divide by 25. Multiply and divide by 25. So once I got able to multiply and divide by 25, in the question it is being asked write in the form of R cos theta minus alpha, means it should be R cos theta cos alpha plus sin theta sin alpha. So you can see that with cos theta cos alpha has to be associated, with sin theta sin alpha has to be associated. So I make that cos alpha is equal to 7 upon 25. So alpha is equal to cos inverse 7 upon 25. When I do by calculator, I get it as 73.74 because 2 decimal places. So what am I going to do? Go back here, write 25. This 7 upon 25 can be written as cos 73.74 degrees cos theta plus 24 upon 25. You can check in the calculator. 24 upon 25 can be written as sine 73 upon 0.74 degrees sine theta. So now this is in the form of cos A cos B plus sine A sine B. So it can be written as cos A minus B theta minus 73.74 degrees. That's going to be the answer for the first part, 3 marks. Second part, hence solve this one. So hence we have to solve 7 cos theta plus 24 sin theta is equal to what it has been there, equal to 15, and theta lies between 0 to 360 degrees, equal to 15. Just now we have proved that this is 25 cos theta minus 73.74 degrees is equal to 15. So cos theta minus 73.74 degrees is equal to 15 upon 25. So theta minus 73.74 degrees is equal to cos inverse 15 upon 25. Then which is, so theta minus 73.74 degrees, cos inverse is I can write 2n pi plus or minus 53.13. Cos inverse 15 by 25 is 53.13. Remember that whenever it is cos, I introduce 2n pi plus or minus. So from there I get, that is a general solution for cos. So I get theta is equal to, let me write at the top in a different color. So theta is equal to 2n pi plus or minus 53.13 degrees plus 73.74 degrees. So this is a general solution in order to get all the values of theta between 0 to 360. So what am I going to do? Substitute n is equal to 0. So I get one answer as plus 53.13 plus 73.74, or what am I going to do? It is, let me move this somewhere there side by, okay. So 73.74, or I use minus 53.13 degrees plus 73.74. So this becomes, what are those answers will become as 126.9 degrees, or 73 minus this one gives me 20.6 degrees. Both are in the range between 0 to 360, so I consider both the angles, no issues. Now when I substitute n is equal to 1, remember pi means 180, so it becomes 360 plus 53.13 plus 73.74, or 360 minus 53.13 plus 73.74. In either of the cases, the answer will be 486.9 degrees and 380.6 degrees. Both are more than 360, so therefore I don't consider those answers. My final answer will be these two numbers, only one decimal place. So when I'm writing the answer for the second part, remember it is one decimal place, but when I'm writing answer for the first part, it should be two decimal place, because in the second part nothing is mentioned, so always angle should be in one decimal place. That's question number 4. Now coming to question number 5. In a certain industrial process, the substance is produced in a container. The mass of a substance in the container T minutes after the start of the program is X. At any time, the rate of the formation is proportional to the mass. Rate of the formation dx upon dt is proportional to mass, which is proportional to x. Although throughout the process the substance is removed from the container at a constant rate of 25 grams per minute. So first of all, dx upon dt is equal to kx, because remove this proportionality symbol and write equal to, but we are removing it at a rate of 25 grams per minute, so minus 25. So net mass will be minus 25. So because he says that it is proportional to mass, I have used proportional to x. Remove that proportionality symbol, write equal to kx, but it is removed, minus 25 we need to be written. Now the values have been given. What are the values? When t equal to 0, x is equal to 1000 and dx upon dt is equal to 7.5. So 75 is equal to k times 1000 minus 25. From there 100 is equal to k times 1000, so k is equal to 0.1. So now my new equation becomes dx upon dt is equal to 0.1 x minus 25, take 0.1 common, x minus 250. This is dx upon dt. That's done in the first part. Now in the second part, solve this equation. So as usual, I don't have sufficient space, so I move this one there. So I need to solve this equation. So how should I be solving this equation? So I take dx is equal to 0.1 times x minus 250 times dt. Then x minus 250, bring this side, is equal to 0.1 dt. Then what am I going to do? Apply integral on both sides. This becomes ln x minus 250 is equal to 0.1 t plus c. So I need to calculate the value of c. So it has been given that in the question, if you remember, when I scroll up, t equal to 0, x is 1000 and dx upon dt is this much. So x is 1000, substitute that one, 1000 minus 250 is 750, t equal to 0 plus c. So c is equal to ln 750. So plug in and get an equation now. Ln x minus 250 is equal to 0.1 t plus ln 750. So ln x minus 250 minus ln 750 is equal to 0.1 t. So ln x minus 250 divided by 750 is equal to 0.1 t. So x minus 250 upon 750 is equal to e to the power of 0.1 t. So from there, x minus 250 is equal to 750 e to the power of 0.1 t. X is equal to 250 plus 750 e to the power of 0.1 t. So x is equal to 250 common, 1 plus 3 e to the power of 0.1 t. That's going to be the answer. Question number 6. By sketching 2 cot x and 1 plus e to the power of x, where x is a radians, has only one root in the interval 0 to pi by 2. So we need to draw the graph for cot x. So first of all, we should learn how does the cot x graph looks like. Okay, so for that, let me, what it says, draw the cot x graph. Okay, so this is x-axis and this is y-axis. Now cot x graph. So I draw an asymptote at pi by pi, and this value is pi by 2. Approximate graph, I'm drawing it out. So approximately the graph looks like this. This is the graph for cortex 0, and extend this x-axis. Okay, so this is x-axis, this is y-axis. Asymptotes are my y-axis and this one, but I want only till 0 to pi. And next equation is 1 plus e power x. So basically e power x graph is like this, passing through 1, but I want 1 plus e power x, so therefore this value 1 becomes 2. So you can see that both the graphs are intersecting at only one point between 0 to pi by 2. So we have shown that. Verify with the calculation that this graph root lies between 0.5 and 1. So f of x is equal to cot x minus 1 minus e power x. So bring all the 2 cot x. So basically 2 cot x or cot x doesn't make any difference. So even you are sketching the graph, so I draw it out in the same way as cot x. Now what I have to prove, that this root lies between 0.5 and 1. So what am I going to do? Substitute 0.5. Use the mode of the calculator in radians. 2 cot 0.5 minus 1 minus e power 0.5. I quickly take the calculator. 2 cot is not available, then you can use tan. 1 by tan minus 1 minus e to the power of 0.5. So when I do, am I getting it out? Provided mode of the calculator in radians. So I get 1.012254173. Next, what am I going to do? I am going to substitute 1. So 2 cot 1 minus 1 e to the power of 1. So I go back and change the value to 1. So am I getting minus 2.434. So you can see that as f of 0.5 and f of 1 are having opposite signs. Root lies between 0.5 and 1. Now I have to prove that this root also satisfies this equation, x is equal to tan inverse. So basically the equation was cot x is equal to 1 plus e power x. Now I have to get that equation. What is that equation? I have to get it out. Let us write x is equal to tan inverse 2 by 1 plus e power x. X is equal to tan inverse 2 upon 1 plus e power x. If you are not getting an idea how to proceed, so what we can do it is, you can do a bottom-up approach. Bottom-up approach means write the previous step. It would have been tan x is equal to 2 by 1 plus e power x. Do the reciprocal on both sides. Tan x reciprocal is cot x. This will become 1 plus e power x upon 2. Then do the cross multiplication. That's it. And then what you can do is you can erase all this. So you get it out, and you can shift it this one if at all you have a place. That's it. It looks as if I have done from top to bottom. You can do a bottom-up approach. Finally, he's asking initial value is x1 equal to 0.7, 2 decimal places, each iteration in 4 decimal places. So the iterative formula, I have space, okay. Iterative formula is xn plus 1 is equal to tan inverse 2 upon 1 plus e power xn. And it has been told that x1 is equal to 0.7, so n is equal to 1. So it becomes x2 is equal to tan inverse 2 upon 1 plus e power x1, which is tan inverse 2 upon 1 plus e power 0.7. So when I do shift tan inverse 2 divided by 1 plus e power 0.7. So I write 0.5 0.5859. Okay, then what am I going to do? I'm going to take n is equal to 2, so it becomes x3 is equal to tan inverse 2 by 1 plus e power x2, which is tan inverse 2 by 1 plus e power 0.5859. I go back and change that value to 5859, so I get 0.6208. Then next I take n is equal to 3, so I get x4 is equal to tan inverse 2 by 1 plus e power x3, so tan inverse 2 by 1 plus e power 0.6208. So I go back and change it to 6208, so I get 0.6101. I may try one more time. N equal to 4, so I get x5 is equal to tan inverse 2 upon 1 plus e power x4, so tan inverse 1 by 1 plus e power 0.6101. So I go back and change in the calculator as 6101, so I get 6134. I stop it here. Why am I stopping over here? You can see that if I round it off this one to 2 decimal places, it becomes 0.59, this becomes 0.62, this becomes 0.61, next one becomes 0.61. So it's repeating, so whenever it repeats, alpha is equal to 0.61. The root is 0.61. Okay, so that's going to be the answer. So you have to write it out as x1, x2, x3, x4 are converging to 0.61, 2 decimal places. The root is 0.61, converging. Question number 7. The complex number 2 plus I is denoted by U, and the conjugate complex is denoted by U star. Show on sketch of an Argand diagram ABC, where A is U, B is U star, and C is U plus U star. So U is nothing but how much has been given? U is 2 plus I. So what will be U star? 2 minus I. What will be U plus U star? Just it is 4. So I have to show this one an Argand diagram. So let me draw an Argand diagram. So 2 plus I, maybe this is U. 2 minus I, that is U, that's A. That's A. 2 minus I. 2 minus I. This may be B. And 4. 4 means 4 comma 0. 2 plus I means 2 comma 1. 2 minus I means 2 comma minus 1. 4 means 4 comma 0. 4 comma 0, maybe it is C. And origin is O. This is x-axis, which is real axis. This is y-axis, which is imaginary axis. So what is he asking? What is the relationship between OAB, OACB? So let me join all the points. O to A, then A to O to A, O to A, then A to C, then C to B, then O to B. So I have drawn, it's almost all looking like a parallelogram, because if you draw properly, neatly in a sketch of graph, it should be looking like a parallelogram. It may not be looking like it over here, but we can write it's a parallelogram. Parallelogram. Then express U upon U star in the form of x plus IY. U upon U star. U is 2 plus I. U star is 2 minus I. So what am I doing? Rationalize, multiply and divide with 2 plus I. So it becomes 4 plus 4I plus I square divided by 2 square minus I square. So it becomes 4 plus 4I. I square is minus 1. 4 minus of minus 1. So it becomes 3 plus 4I by 5. So it becomes 3 upon 5 plus 4 upon 5I. Finally, by considering the arguments of u and u star, or otherwise prove that tan inverse 4 upon 3 is equal to 2 tan inverse 1 upon 2. So u upon u star. So argument of u upon u star is equal to, there is a formula, argument of u minus argument of u star. That is a formula. So argument of u upon u star, which is 3 upon 5 plus 4 upon 5i, should be equal to argument of 2 plus I minus argument of 2 minus I. So argument means tan inverse y term divided by x term is equal to tan inverse 1 upon 2 minus tan inverse minus 1 upon 2. 5 gets cancels. Tan inverse 4 upon 3 is equal to tan inverse 1 upon 2 plus tan inverse 1 upon 2. So from there I get tan inverse 4 upon 3 is equal to 2 tan inverse 1 upon 2. So this formula has to be remembered. Argument of u upon u star is equal to argument of u minus argument of u star. Question number 8. Find the exact coordinate of M. Where is M? M is the minimum point of this curve. So what should I do? Find the derivative and equate to 0. So y is equal to x to the power of 1 upon 2 ln x or ln x. So dy by dx is equal to x power 1 upon 2 divided by x. Ln x derivative is 1 upon x. Ln x, x power 1 upon 2 derivative 1 upon 2, x power 1 upon 2 minus 1 is minus 1 upon 2. So now equate this to 0. So x power minus 1 upon 2 plus 1 upon 2 ln x times x power minus 1 upon 2 is equal to 0. So what I can take common, x power minus 1 upon 2 common, 1 plus ln x by 2 is equal to 0. So this gives me two answers. X power negative 1 upon 2 is equal to 0. 1 plus ln x upon 2 is equal to 0. X is equal to 0 is not the value of m, because m is not at the origin. It is after origin. So ln x upon 2 is equal to minus 1. Ln x is equal to minus 2. X is equal to e power minus 2. So what is the x coordinate of m? This is the x coordinate of m, which is e power minus 2. That's it. Use the integration by parts to find the area of the shaded region enclosed by the curve x-axis and the line x is equal to 4. So it is starting from 1 to 4. So integration by parts. Integral x power 1 upon 2 ln x from 1 to 4. For this I use the acronym ILATE. ILATE. What is this ILATE? I stands for inverse trigonometric functions, L stands for logarithmic functions, A stands for algebraic functions, T stands for trigonometric functions, E stands for exponential. Detailed video for this ILATE will be uploaded. You can check in the link over there, which is above. So over here I have logarithm and algebra. So logarithm is the first function, algebra is the second function. So the formula is, in first function, integral of second function. Ln x, x power 1 upon 2, the integral is x power 3 by 2 by 3 by 2, minus integral of derivative of the first function. Ln x derivative 1 upon x, and carry forward this. So derivative of first function, integral of second function. X power 3 by 2 by 3 by 2. I know that who don't know this ILATE concept or first function second function will be finding difficult to understand this. They can look to the link over there at the top, which is given to the similar kind of questions of ILATE. So it becomes 2 upon 3 ln x times x power 3 upon 2 minus 2 upon 3 integral x power 1 upon 2 dx. So what does it becomes? 2 upon 3 ln x, x power 3 upon 2 minus 2 upon 3 x power 3 upon 2 upon 3 upon 2. The limits are 1 to 4. Now I substitute the limits 1 to 4. So substitute the upper limit, ln 4 power 3 by 2 minus 4 by 9, 4 power 3 by 2. Substitute the lower limit, 2 upon 3 ln 1 1 power 3 by 2 minus 4 by 9, 1 power 3 by 2. So directly I'm writing the answer. Answer is 4.28. That's question number 8. Finally, question number 9. Question number 10 is from vectors, which is planes, has been deleted. We can use that one, has been done into further maths. So therefore we are doing only 9 questions. Now 10 upon 2 minus x times 1 plus x square is equal to a upon 2 minus x plus bx plus c upon 1 plus x square. So 10 is equal to a times 1 plus x square plus bx plus c times 2 minus x. So plug in x is equal to 2. If I plug in x is equal to 2, 10 is equal to a times 5 plus bx plus c times 0. So 5a is equal to 10, a is equal to 2. I get the value of a is equal to 2. Then next, what should I do? Comparing the coefficients of x square. There is no x square over here, so 0 on the left side. A times b, a minus b, because a times x square is ax square, bx times minus x is minus bx square. So a is equal to b, so b is also equal to 2. Now I need to get the value of c. For this, what I can do, substitute any value of x. At random, let x is equal to 0. So 10 is equal to a times 1 plus 0 plus c times 2 minus 0. So 10 is equal to a plus 2c. A was 2, 10 is equal to 2 plus 2c, 2c is equal to 8, c is equal to 4. So what is my partial fractions now? 10 upon 2 minus x times 1 plus x square can be written as a is 2 upon 2 minus x plus bx plus c, 2x plus 4 upon 1 plus x square. That's the partial fractions. Now expand this one. Expansion till the coefficients of x cube, simplifying each coefficients. So I have to expand each one. So first I take 2 by 2 minus x. So what am I going to write? 2, take 2 common, 1 minus x upon 2. So it becomes 1 minus x upon 2 whole to the power of minus 1. So 1 minus x upon 2 whole to the power of minus 1. Expand that, a plus nx plus n times n minus 1 by 2 factorial x square plus n times n minus 1 times n minus 2 by 3 factorial x cube. So it becomes 1 plus x upon 2, 2 gets cancels, minus minus also gets cancels, it becomes x squared by 4, then 3 and 2 factorial gets cancels, 3 times minus gets cancels, plus x cube by 8, and so on. That is the first one. Second one, we need to expand the second one to 2x plus 4 times 1 plus x square. 2x plus 4 upon 1 plus x square. So it becomes 2x plus 4 times 1 plus x square whole to the power of minus 1. So it becomes 2x plus 4 times a plus nx. No need to do the other part because it becomes x power 4. I want only till x power 3. So multiply this one, 2x minus 2x cube plus 4 minus 4x square. Now I have these two answers. I need to add these two answers. So when I add, I can see that I use a color combination. 1 and 4 adds up to 5. Then x terms, x upon 2 and 2x will become 5x upon 2. Then I may use this one. X square upon 4 minus 4x square upon 4 becomes minus 15x square upon 4. Then finally x cube upon 8 minus 2x cube upon 8 is minus 16 plus 1 minus 15. Minus 15 x cube upon 8 plus and so on. That's all. That's the answer. If your expansion is correct, you will be getting the correct answer in the first attempt itself only. So that completes the paper. All the 9 questions. 10th question is deleted, which is from vectors plane concept. So that was the paper, CAI 2006 P3. See you in the next paper.